Did you know that NASA are returning to the moon, and it could be as soon as 2026? The last person left the moon in 1972. Since then, we've never been back. Our ability to study our lonely neighbour drastically lowered. Science and progress stopped in its tracks. For decades, we've heard of rumours of a possible return, often willed by those inspired by Apollo. Artemis is NASA's new decade-long project, with a budget stretching into the tens of billions. The ultimate goal for the project is to put humanity back on the moon, but this time to stay. NASA is setting up a small permanent base on the moon's south pole, allowing for astronauts to rotate from Earth, just like they do on the International Space Station. The moon base will allow for scientific experiments on the surface. It will also enable NASA to work with private companies that may be interested in mining on the moon for some very important reasons we'll get into later. The Artemis project, as with Apollo, will stretch for years, with every launch moving a step closer to the ultimate goal. At present, Artemis is divided into three major sections like Apollo: Apollo 1, Apollo 2, etc. But unlike Apollo, this time there's backup. SpaceX, as well as the European, Japanese and Canadian space agencies are all playing a part in landing the next man and first woman on the moon. The Artemis project is the most ambitious program attempted by humanity since Apollo, but far exceeds its goals. Artemis will play a large role in pushing and proving that humanity is ready for the next step: Mars. Artemis 1. Artemis 1 is the uncrewed section of the project, allowing NASA to test its new rocket system, SLS, in conjunction with the newly developed Orion spacecraft. The Artemis 1 mission will last for 3 weeks, blasting 280,000 miles to the moon. The Orion spacecraft will get within 60 miles of the moon's surface, with the craft orbiting the lunar body for 6 days before returning back home to Earth and attempting re-entry at a speed and heat never attempted before. This will allow NASA to examine the mission data and correct any issues they may have made in their predictions before risking the lives of astronauts. Artemis 2. The Artemis 2 missions will follow shortly after Artemis 1, this time upping the stakes and hopefully reigniting the planet's interest in space, as we see mankind near the moon for the first time in decades. Artemis 2 will send astronauts around the moon's orbit and back home again. The mission's primary focus will be testing, with the team testing the life support systems and disconnecting from its propulsion system before reconnecting, practicing docking procedures. Another big difference between the Artemis 1 and 2 missions will be the way in which we get to the moon. Both missions will use the same rocket to get to space. However, Artemis 1 would have used Earth's gravity to slingshot the craft to the moon. Artemis 2 will use cryogenic propulsion from its ICPS to make the journey faster. This isn't because time is precious, but because of radiation. Between Earth and the moon, the astronauts will have to pass through the Van Allen belt. The Van Allen belt is an area around Earth created by the magnetic field. This belt traps energetic charged particles. Protecting astronauts against these particles is difficult, so the ICPS boosters will allow the craft to pass through the danger zone at speed, causing as minimal damage as possible to the humans inside the craft. Artemis 3. The third and final phase, Artemis 3, will be the moment the world has been waiting for. 4 astronauts will leave Earth and begin the long voyage to the moon. Humanity will be watching with great anticipation at this point, as 2 astronauts begin a 4-day orbit of the moon, whilst their colleagues, 1 woman and 1 man, become the next humans to set foot on the lunar surface. Although the date could get delayed, at present it's expected that 2026 will be the year that humans return to the moon. Whilst on the surface, astronauts will be assigned tasks and experiments, just like during the Apollo landings. Astronauts will be searching the lunar craters for frozen water in order to support and establish a future base. Ahead of time, NASA and SpaceX would have also fired equipment to the moon's surface with unmanned rockets. This equipment will include vehicles such as drivable rovers and technology to help life support systems. Experiments will also focus on food creation and habitat testing. During the Apollo missions, astronauts returned 382 pounds of moon rock and soil back to Earth for scientists to study. Artemis will be no different, bringing back as much as possible to aid research. Once out of the lander and back in Orion, the astronauts will orbit the moon one last time before slingshotting home using gravity. The craft will enter Earth's atmosphere at 25,000 miles per hour, heat shield first to protect the crew from the 5,000 degree temperature. At 300 miles per hour, a series of parachutes will release, slowing the craft down to just 20 miles per hour before splashing down in the ocean in typical NASA fashion. Upon the mission's success, various landings will follow, as the moon base is slowly developed over time. We'll get to why NASA has chosen to create a moon base shortly, but first, one more exciting stage. Throughout the Artemis project, NASA is also aiming to put a space station in orbit around the moon. This space station will be called Gateway. Gateway will allow future ships to dock in moon orbit before transferring to a lander. This lander will make transfer from moon orbit to the surface easier. Gateway will also be built with future expansion in mind, with many sections being able to be added at a later time. NASA is hoping that Gateway can not only assist with the Artemis project, but also act as a stopover for further missions, such as those planned for Mars in the 2030s. So why go back now, after 50 years? Although the project on the surface provides research and exploration as its key driver, there is an underlying motive. We may have just entered the next space race, and potentially with recent developments in Ukraine, a Cold War. But the key driver, the motive hidden between the lines, is energy. 5 countries have so far declared interest in mining on the moon: the USA, Russia, China, Israel, and India, surely with more to follow. Russia is also developing a space station that will orbit the moon to rival NASA's Gateway, aiming to put Russians on the moon in 2030 and begin a moon base in 2034, even going as far as warning America not to colonize the moon. China have landed 2 rovers on the moon in the last decade, Yutu and Yutu-2. China also has objectives to build a moon base like America on the South Pole, so they will also have to land their first men in the coming years. So why all the fuss? There are lots of materials on the moon that are common on Earth: water, silicon, aluminium, titanium, and precious metals. But there is one that is rare on Earth, and rather important: helium-3. Helium-3 is an isotope of helium. Helium, but with a different number of neutrons. At the moment, nuclear power in power plants across the world is created using a process called nuclear fission. This involves splitting a nucleus into even smaller nuclei. It provides great amounts of energy, but at a cost. Uranium has to be mined, damaging the planet. The process of fusion itself creates radioactive waste that remains dangerous for thousands of years. Nuclear fusion is the next step in nuclear technology. Although we are not quite there yet, a team in England brought us a step closer in 2022. It'll still be a couple of years until we master the process. The world's first live reactor is planned for 2035. With fusion, you don't have to use a material as dangerous for the planet as uranium. Nuclear fusion uses light gases such as helium-3 and tritium that combine and become helium-4 in a flash of great energy. Energy without radioactive waste, clean energy that can save the planet in the fight against fossil fuels. Helium-3 is rare on Earth, only found as a byproduct of nuclear weapon manufacturing, something we'll hopefully do less of in the future. Helium-3 can be found in solar wind. Earth is protected from these winds by its magnetic field. The Moon doesn't have a field of its own, leaving it exposed. Over billions of years, this light gas has been deposited throughout the lunar surface. However, it's not distributed evenly. There are certain areas of the Moon with almost all the fuel. It's a race to get there. Finders keepers, but with the future of energy. It's estimated that there is enough helium-3 on the Moon to power the planet for 10,000 years, with a value of $3 billion per ton. If a rocket such as SpaceX's Starship with a payload capacity of 100 tons were to make a trip there and back, its total cargo value could be worth over $300 billion. The value of one of these shipments would be enough to disrupt the global economy, tipping the balance in favour of whoever controls the supply. Welcome to the space race too. Thank you for watching. If you enjoyed the video, please like and subscribe to the channel. Stay safe.